So we'll use tangency techniques to construct this lever. First, we measure 75 from the axis. I'm drawing the arc of radius 19. And then I'll draw the hole within it. So these are concentric. The hole has a diameter of 16, so radius is 8. Now we are told that there are two of these features. The other feature is 140.5 away from this current one. So I measure 140 to my left, and it is also 44 millimeters downwards. So that will be the center of the other feature with the same dimensions. So same construction. The hole is 8 in radius and the arc is 19 in radius. I'm just drawing in the center lines. And now I'll draw the features at the center. So I have a circle there and an arc. I'll represent those two. So the inner circle has a diameter of 75 and the outer one has a diameter of 88. Now we are almost ready to construct our tangential arcs. But before we do that, let's first draw tangential lines. So a tangential line from that circle to that. Make sure you are drawing a tangent. So a tangential line on the upper part as well. Make sure you actually draw a tangent and not a chord. Okay. Now on the other side, we don't have tangential lines, but we have tangential arcs. So we are ready to draw our arcs, tangential arcs on the other side. So R19 and R38 are external tangents, so we add their radii, and that gives us 57. So from the center of R19, we open to 57 and draw an arc. And then diameter 88 is also R44. So from the center of R44, we would open to 82, radius of 82, and that's because R44, which is also diameter 88, and R38 are external tangents. So open to 82 and you describe an arc. Now the intersection of these two arcs will be the center for R38. So you stand at that intersection, and then you open to a radius of 38 and draw an arc, and that arc will be tangent to R19 and R44. Okay, so we're done with that. Now we're going to take care of R125. So for R125 and R19 are interior tangents. So we would subtract their radii, and that will give us 106. So from the center of R19, we open to a radius of 106 and we draw an arc. Just like that, 106, and we draw an arc. Now R125 and R44 are interior tangents, so we subtract their radii, and that will give us 81. So from the center of R44, we open to a radius of 81 and draw an arc. Alright, now the intersection of these two arcs is the center for R125. So with the pin of your compass, you stand at 120. You stand at the intersection and you open to a radius of 125, and you draw the arc, and that arc will be tangent to R19 and R88. Now we want to draw the hexagon. So let's draw a center line which is deviating 15 degrees with respect to the vertical, and that's what I've just drawn. And now I draw another line which is 90 degrees from the initial center line. So the initial center line is 15 degrees away from the vertical, and then I draw another center line which is 90 degrees to the 15-degree center line. So it's very important that you do this and you do it this way, else you won't get the correct solution. Now we draw a circle with the diameter shown, and now, so that is, I'm just placing the center line. Okay, so we draw a line that is 90 degrees to the center line, but that line should also be tangent to the circle. So just like that, you make sure that the line you've just drawn is tangent to the circle, and we draw another one in this position. So this one is also tangent to the circle and 90 degree to the, for lack of a better word, let me call it the horizontal line. By the horizontal center line, I'm referring to the one which is 15 degrees from the actual horizontal. Okay, so we are going to need our set squares, so I'll just improvise by drawing a 60-degree set square. So we're going to use our 60-degree set squares to continue and then to finish things up. So you take your 60 degree set square and you arrange the set square such that the hypotenuse there touches the circle, just like that. So that is how you arrange your set square, right? So you have the 60 degree side touching the circle, just like that. Make sure it touches the circle such that you get tangency, not your 45 degrees set square, but rather your 60 degrees set square. And you are using the 60 degree side. And then you draw a line that touches the circle, just like that. Now you move your set square to the other side. So you move your set square to the other side, and then you move it until it touches the circle, and then you draw a line. And now you do the same thing on the opposite side. So you draw a line and another line with your set square, and that basically is our solution. So because I'm using the software, I will clean the unwanted parts for legibility, but for you, you can keep the construction lines in place and then just dip in the required object lines. And that basically is our solution. So after putting on the dimensions, this is our final solution.